Module 2. Population and Development to Global Climate Change. 1. Population and Development. When we talk about population and development in environmental management, we're looking at a delicate equation: the size of a population, its rate of growth, and the level of economic development. These three factors interact to influence environmental impacts. A population that grows too quickly can strain infrastructure, housing, food supply, and water systems, even in wealthier nations. On the other hand, a population that is stagnant or shrinking may have less environmental pressure but can face economic challenges, such as a reduced workforce to support an aging population. Development, ideally, should be sustainable, meaning it meets the needs of the present without compromising the ability of future generations to meet their own needs. This is not just about balancing budgets and building infrastructure, it's also about managing natural resources wisely. For example, a country investing in industrial expansion must consider pollution control measures to avoid degrading air and water quality, which could harm both human health and long-term economic productivity. The relationship between population and development can also be understood through the lens of the demographic transition model, where societies move from high birth and death rates to lower rates as they industrialize and modernize. This shift often reduces population growth over time, but the environmental impact can increase if industrialization relies on heavy resource extraction and fossil fuel use. An effective environmental management system integrates population data into national and local development planning, ensuring that growth, whether in people or in economic terms, does not exceed the capacity of ecosystems to support life. 2. Water, hydrologic cycle and human use. Water is the lifeblood of all ecosystems and is central to environmental management. The hydrologic cycle, also called the water cycle, describes the continuous movement of water between the atmosphere, land, and oceans. Water evaporates from oceans and land surfaces, condenses into clouds, falls as precipitation, and eventually returns to the oceans through rivers and groundwater flow. While this cycle is continuous, the availability of fresh water is limited. Most of the Earth's water is salty, only a small fraction is fresh and accessible for human use. And that small fraction is unevenly distributed across the planet. Human activities, agriculture, industry, domestic use, all require large amounts of water. Agriculture alone accounts for around 70% of global freshwater withdrawals. This heavy use often leads to over-extraction of rivers and aquifers, lowering water tables, drying wetlands, and reducing river flows. Pollution also threatens water quality. Industrial effluents, untreated sewage, agricultural runoff, and oil spills can make water unsafe for drinking, fishing, or recreation. An environmental management system addresses both the quantity and quality of water, promoting efficient use, protecting watersheds, restoring wetlands, and treating wastewater. Integrated water resource management is one approach that balances competing needs: drinking water, irrigation, energy production, recreation, while protecting ecosystems that depend on healthy water systems. 3. Soil, the foundation for land ecosystems. Soil is more than just dirt. It's a living system made up of minerals, organic matter, water, air, and countless organisms. It provides the foundation for plant life, which in turn supports entire terrestrial ecosystems. Healthy soil retains water, stores nutrients, and hosts beneficial organisms that help plants grow. Unfortunately, human activities often degrade soil through erosion, overgrazing, deforestation, and excessive use of chemical fertilizers or pesticides. This degradation can lead to desertification, the transformation of fertile land into desert-like conditions. Soil conservation is therefore a key part of environmental management. Strategies include planting cover crops, practicing crop rotation, reducing tillage, reforesting degraded land, and maintaining vegetation along riverbanks to prevent erosion. Restoring degraded soils can take decades, but preventing damage is relatively straightforward. It requires policies and practices that value soil as a non-renewable resource in human timeframes. 4. The production and distribution of food. Food production depends on healthy soils, adequate water, favorable climate, and biodiversity, from pollinators to natural pest predators. Modern agriculture, however, often prioritizes yield over long-term sustainability, relying on monocultures, heavy chemical inputs, and irrigation systems that may not be sustainable. Distribution adds another layer of complexity. While the world produces enough calories to feed everyone, hunger persists due to poverty, inequality, political instability, and infrastructure limitations. At the same time, in wealthier regions, food waste is a major issue. Large amounts of edible food are discarded due to cosmetic standards, oversupply, or spoilage. An environmental management approach to food systems includes promoting sustainable agriculture, such as organic farming, agroforestry, and integrated pest management, reducing waste, and ensuring equitable access to nutritious food. Local food systems, urban gardens, and improved storage and transport infrastructure can also reduce environmental impact and increase resilience to disruptions like climate change. 5. Pest and pest control. Pests, organisms that compete with humans for food, spread disease, or otherwise cause harm, are a natural part of ecosystems. But when pest populations explode, they can cause significant agricultural and health problems. For decades, pest control relied heavily on synthetic chemical pesticides. While effective in the short term, overuse of these chemicals has led to pesticide resistance in pests, killed non-target species, including beneficial insects and birds, and contaminated soil and water. Integrated pest management, IPM, is a more sustainable approach. It combines biological control using natural predators, cultural practices, crop rotation, planting pest-resistant varieties, mechanical controls, traps, barriers, and minimal, targeted pesticide use when necessary. Environmental management systems encourage IPM because it reduces reliance on chemicals, protects biodiversity, and maintains ecosystem balance. 6. Energy from fossil fuels. Fossil fuels, coal, oil, and natural gas, have powered industrial civilization for over a century. They are energy-dense, relatively easy to transport, and have supported massive economic growth. But they come with significant environmental costs. Burning fossil fuels releases greenhouse gases, GHGs, like carbon dioxide and methane, which trap heat in the atmosphere and drive climate change. It also produces air pollutants that harm human health, particulate matter, sulfur dioxide, nitrogen oxides. Fossil fuel extraction can damage landscapes, pollute water, and harm wildlife. Oil spills, coal mine collapses, and fracking-related earthquakes are just some examples. Transitioning away from fossil fuels is a major challenge for environmental management because they remain deeply embedded in economies and daily life. Strategies include improving energy efficiency, investing in renewable energy, and implementing policies like carbon pricing to reflect the true environmental cost of fossil fuels. 7. Nuclear power. Nuclear power generates electricity without producing greenhouse gases during operation, making it an attractive low-carbon energy source. However, it comes with its own environmental and social concerns. The main issues include radioactive waste, which remains hazardous for thousands of years, and the risk of catastrophic accidents, such as Chernobyl in 1986 and Fukushima in 2011. Nuclear plants also require large amounts of water for cooling, which can affect aquatic ecosystems. Supporters argue that with modern safety measures, nuclear power can play a key role in reducing fossil fuel dependence. Critics point to the high cost, waste management challenges, and potential security risks. Environmental management systems that include nuclear power must ensure strict safety protocols, secure waste storage, and transparent public communication. 8. Renewable energy. Renewable energy sources, such as solar, wind, geothermal, hydropower, and biomass, draw on resources that are naturally replenished. They produce little to no greenhouse gas emissions during operation and generally have lower environmental impacts than fossil fuels. However, renewables are not impact-free. Large hydroelectric dams can disrupt river ecosystems and displace communities, wind turbines can affect bird and bat populations, biomass production can compete with food crops for land. An environmental management approach to renewables focuses on careful site selection, technological innovation to minimize impacts, and integrating renewables into the grid alongside energy efficiency measures. The ultimate goal is an energy mix that meets human needs while staying within ecological limits. 9. Environmental hazards and health. The environment affects human health in countless ways, from the air we breathe to the water we drink, the food we eat, and the climate we live in. Environmental hazards include chemical pollutants, biological agents, and physical dangers like extreme heat or radiation. Some hazards are acute, like a chemical spill or a hurricane. Others are chronic, like long-term exposure to air pollution or contaminated drinking water. Vulnerable populations, children, the elderly, the poor often suffer the most. Environmental health management involves identifying hazards, assessing risks, and implementing measures to prevent or reduce exposure. This can include air quality regulations, safe drinking water standards, occupational safety rules, and public education campaigns. 10. Global climate change. Global climate change is perhaps the most urgent environmental issue of our time. Driven primarily by the accumulation of greenhouse gases from fossil fuel combustion, deforestation, and industrial processes, climate change is altering temperature patterns, precipitation cycles, and the frequency and intensity of extreme weather events. The impacts are wide-ranging: melting ice caps and rising sea levels, shifting species distributions, changing agricultural productivity, increased risk of wildfires, and more frequent heatwaves. Climate change also amplifies other environmental challenges, such as water scarcity, biodiversity loss, and public health risks. Addressing climate change requires both mitigation, reducing greenhouse gas emissions, and adaptation, adjusting human and natural systems to cope with the changes already underway. This includes investing in renewable energy, protecting and restoring forests, improving building efficiency, and developing resilient infrastructure. Environmental management systems play a central role in climate action by integrating climate considerations into policies, business practices, and community planning. Closing remarks for the course. We've now walked through the major themes of Introduction to Environmental Management System, from the scientific foundations of ecology to the complex interplay of politics, economics, and human behavior, from the basic needs of living things to the global challenge of climate change. The key takeaway is that environmental management is not just about reacting to problems, it's about anticipating them, preventing them where possible, and designing systems that allow humans and nature to coexist in a sustainable balance. Whether you're working in policy, engineering, business, or community development, understanding these environmental principles will give you the tools to make informed decisions that protect the planet while supporting human well-being.